Hello, everyone. We're going to get started here in a moment. Just have quite a few people still joining, so just bear with us. All right, we're going to get started. Thanks, everyone, for joining today. Today's webinar is titled The Evolution of the TMC in Traffic Management, Considerations Moving Forward. The webinar is coordinated by the ITS Canada Advanced Traffic Management System Technical Committee. If you're not familiar with the ATMS committee, we're a group consisting of public, private sector, and academic members. The committee meets around every 2 months to discuss lessons learned, challenges, and considerations related to ITS and traffic management. The committee is also involved in coordinating content for ITS Canada membership, i.e. the webinar today, as well as assisting with coordinating the annual conference and regional workshops when possible. If you're interested in learning more about the ITS Canada ATMS Technical Committee, please feel free to reach out to myself, Jonathan Darton, or co-chair Jonathan Ford from the City of Winnipeg, who's on the line as well. For today's session, we are fortunate to have 2 presenters lined up. The first, titled Using Waze Data and Free Tools as Traffic Sensors, presented by Michael Schnuerle, Data Officer, Office of Civic Innovation, Louisville Metro Government. The second, titled Traffic Management Centers of the Future, by Matt Lee, Associate Vice President, ITS Operations with ACOM. Before we get into it, just a quick note on the format. So following each presentation, we'll have a few minutes for questions. Like any webinar, please submit your questions through the webinar control panel. It'd be appreciated if you could do that during the presentation so we can, with our best effort, try and coordinate the questions so that we're ready in advance. So thank you for that. Just going to transition control over to Michael, and we'll get started.
Okay, thank you for that introduction. Can you see my screen?
Yes.
Okay, great. Go ahead and present. All right, so my name is Michael Schnuerle. Good job on the pronunciation. I am the Chief Data Officer in Louisville, Kentucky in the United States. I'm in the Office of Civic Innovation and Technology, and I'm going to talk about how to use Waze as basically Waze data as traffic sensors. So this is an overview of my office to give you a little bit of context of where I sit in the government. Mayor Greg Fischer is our city mayor. He was elected and created the office in 2010. Grace Zimmerl, the Chief of Civic Innovation and Technology, reports to him, and I report to Grace. And what's interesting maybe with us is that our IT department reports to our Chief of Civic Innovation. So that puts us in a nice position to try out new and interesting things across the enterprise and work with different departments to try to move the needle on some initiatives. My responsibilities actually don't align much with what I'm talking about today, but the sort of partnerships and data things that I've been doing have led to the creation of some of these tools and initiatives that I am talking about. So I'm responsible for data management and analytics type projects across the city. I manage our city's open data program. I run a data governance team of 60 plus cross-departmental employees, so people that deal with data in their departments. We do trainings and write policy and things like that. One of my job responsibilities is also collaborations with universities, private companies, nonprofits, and other governments on different projects. And we have a kind of a public-facing component with open data and public hackathons. So one of these collaborations with other entities is what I'm going to talk about today. You, as members of ITS Canada, probably think a lot about IoT sensors across your city. How do you pay for those? Where do you put them? What are they going to be? What information can they gather? For what purpose? So a general question that you could ask is, how do you get sensors, specifically traffic and vehicle sensors, across your entire city that can measure for things like speed, congestion, or problems and issues you may have? So one way to do this, which is fine and it works, is you can spend millions of dollars on IoT devices, the connected infrastructure for that, whether that's in the ground or over the air, and then the maintenance of those devices. Or maybe you can pay a company that gathers this information, someone like here, or other companies annually for different levels of data and services around that. And what I want to talk about today is, what if I told you there was a free citywide source of data right now that can give you real-time and historic speed, congestion, and problem information? So the answer to that question starts with the Waze app, and I'm sure almost all of you are familiar with the Waze app. Consumers use it to navigate from point A to point B. Even in Louisville, Kentucky, which is has a population of about 800,000 people or so, we have 50,000 active daily users here. So that's a pretty significant user base, and it kind of spans much of our city. So people are using the Waze app. So Waze has a program called the CCP program, which allows data sharing between cities and Waze. This CCP program stands for Connected Citizens Program, and it's a free two-way data exchange between cities. So cities provide information to Waze about road closures and other details about what's happening with construction. And Waze provides real-time anonymized proprietary incident and slowdown information from the people that use the Waze app. So an example of what you publish as a city, and probably many of you are already doing this, but you publish out road closure and construction data in a certain format. We publish it out as open data in a file that we aggregate from multiple sources. We update it daily, sometimes more than that if we have to, and it has closures, construction, utility work, and it's ingested by Waze for all Waze users to use. So when you look at a live map of what's happening, whether you're navigating or just browsing, you can see all the construction and things that the city has reported, in addition to the other things that the Waze users have reported. So it's nice to do that anyway. You're getting information into the hands of people that are using it, and if you publish it as open data, other companies and entities can use that information as well. So you also get access as a partner to Live Map, which is an online map of segments of road that you can manage and look at specific slowdowns and kind of get a snapshot of key areas in your city. So that's a nice feature. But they also provide a data feed to cities. And so this data feed is near real time. They recommend hitting it every 2 minutes, but you can actually hit it more frequently if you want, and it's updated. But it gives you information about traffic jams or congestion that's passively collected by all the Waze users. So just by using the app, that information is getting collected. And then it has actively submitted alerts from users. So things like a user's driving and they submit information about a pothole or roadkill, or there's a broken street light or something like that, an accident. There's also some irregularity information where if the traffic slows down a lot, you can get some irregularity notices. So it's a broad swath of kind of passive and active data that we get back. So I'm just going to show you if you use that data, a few different use cases that we have used for this. One is post-event analysis. So we have a fireworks show that kicks off the Kentucky Derby here, which is 2 or 3 weeks of festivities. So we can make an analysis or even a fun animated map of people leaving downtown after the event, and you can see the congestion there. We close off a number of different streets every year, and so we can look at how the traffic flows one year so that the next year we can improve it, the closures, and try to get people out and back to their homes if they're using a car faster. Another thing that we use it for is looking at change in jams after some sort of retiming or road configuration change. So we can do a road diet or change the synchronization of lights along the corridor, and we can do it's relatively simple analysis, but the data is good enough where you can make some inferences about, did you help the situation at what time of day, or did you hurt the situation, and make adjustments after that. And you get it in real time, so you could look at it day to day or week to week and compare different time periods. We also use it for aggregating pothole report information with our 311, which is our service call line. So people can report potholes through a phone number or through the Waze app, and we actually ingest those as well. And one thing we found is that Waze usage for pothole reports is much higher on faster roads, which you might expect, where it's just a lot of where the Waze users tend to maybe use the Waze app to navigate versus the slower neighborhood roads. And so you kind of get another set of data that you're not getting from a phone call from residents or using an app, a different app. And then traffic engineers, we've been using this data with traffic engineers as well. So we can do the traffic study type use case that I kind of touched on before. We can look at the changes to a corridor based on tweaks. We can do hotspot analysis across the entire city, which helps us prioritize our resource and focuses. The traffic department can actually use this data to detect faulty non-connected equipment. For instance, induction loops or sensor plates. What you all know, maybe as if you're a traffic engineer, how well you know your street system. And so sometimes my team in the innovation office would show the traffic team one of these Waze maps or analysis, and just at a glance, by looking at the congestion there over time, historically, they can say, oh, there must be a broken piece of equipment just by looking at the visual of the data. And that's something they would not have known because residents don't always report that. They don't know what to report, or they might not even know that it's a major problem. And then that has happened a few times, and they've actually gone out and found faulty equipment and fixed it. And then post-event analysis, like I mentioned. Another thing that they've done is used it for a hotspot analysis. So we've done this is kind of like maybe a high-level data report off of the analysis, but basically defining geographic corridors for different jams and traffic irregularities across the whole city, and finding out severity of delays at different times of day, different time segments, and then prioritizing a top 12 worst corridors list based on this analysis. And that really helps them look at those areas to see what they can do to improve it. We also found a lot of uses in other departments. So the police can monitor a reported road to check for speeders. So what happens is, this might be a Louisville specific use case, but if someone calls and says they have seen a speeder on the road, we are required to send a police officer out to monitor that segment to see if there are speeders. But instead, we can now use the Waze data to determine speeds along that segment in general, to determine what time of day or what day of the week we might want to send that officer out before we send them. So it's a way to save some of our officers' time instead of having them sit there for days. Many cities also, we haven't done this yet, but we can point our idle traffic cameras to the location of reported collision automatically. We started to pilot this in our city. And And then Public Works can ingest other information, and the traffic team can too as well, for like, for instance, broken traffic lights is a report that they get an alert on. And with many of our traffic signals not connected, we can get that information as if it was connected and if it went offline. These are some other use cases. Vision Zero analysis we're using it for. Something that's not on here is air pollution control mitigation, to look at changes in corridor congestion before and after, and try to estimate the amount of traffic congestion and pollution generated in that area. And that's part of our federal reporting requirements. So we're looking at using Waze data for that. And then some citizen-facing notifications based on their own custom areas. That's an app, a web app that we're building right now. Another city, so this is from Massachusetts. This is actually Massachusetts, the state Department of Transportation. They shared this example where they use it for accidents, collisions on the road, and they will typically, up to 4 minutes before a 911 call comes in, they'll get the alert and the location of a collision. So they can get people on the scene much faster than if they just wait for the 911 call and wait for the person on the phone to try to communicate the location of that collision. So now I'm going to talk about an open source project that we built that you can use as well to do pretty much all these things we mentioned here. It's what we use to do all those things. So using the CCP data that Waze provides is complicated. It kind of comes in a fire hose of data, and it has a few issues, and so you need to do some cleaning, and can be a little bit confusing. But I know of jurisdictions that have spent hundreds of thousands of dollars on the infrastructure, databases, and reporting tools just to create a solution to look at this Waze CCP data. So what we created, with the help of many other cities around the world, and actually even private companies and federal governments as well, is a open source solution to process the data. We call it Waze Warp. And Warp stands for Waze Analytics Relational Database Platform. And it takes the Waze CCP data feed and processes it into a cloud database system for historic and real-time querying, analysis, API hooks, and maps. There were 80 governments that were on board supporting it initially. Over 15 are using it. And the total cost for this, the code itself is free, and we do patches on it and updates. But the cost for you would be around $200 a month in cloud computing, storage, and data processing costs. The development of the project, interestingly, was funded by a combination of cities pooling their money, of Amazon Web Services giving money basically to a local company here called Slingshot. They are a cloud services web developer. So Amazon saw the value in this open source project, paid a local developer to build a platform to the spec of multiple cities. So the cities became the project managers on this project. And we were able to build version 1 and version 2, and we're wrapping up version 3 of this from that funding and from funding from other cities like Louisville, Centennial, Colorado, and private companies like InterDev in the United States. Just to give you an idea, this is the cloud infrastructure that gets deployed currently to Amazon Web Services. We built it to be cloud agnostic, and Microsoft is working on an Azure version, which is about 80% complete, and another entity working on a Google Cloud version, which actually might be done first. But basically, the way this code works is you don't have to set up all these little pieces up in the cloud. The code itself deploys all these pieces, and then with a little bit of more code, you can destroy all these pieces as well, or update all of them. And so it's a really nice way to manage a very complex set of infrastructure. All the code and the instructions on how to deploy it is on GitHub at the URL. So Louisville Metro is our city GitHub account page, and then the Waze CCP processor is the name of it. You can actually, it's probably at the top of I think it's pinned to our page, so you can find it pretty easily. And what's interesting about this platform is once multiple cities deploy this, then it becomes a sort of schema and a database and a platform, like a software platform that other people can build integrations on top of. So Cardo, for instance, has built a connector into it. So if you're a Cardo user, you can send in your own personal cloud Waze Warp credentials and endpoint. And then basically you can pull in a subset of the data for a certain time range into a Cardo map automatically without having to do any code, and you can do that whenever you want. The Power BI example on the right, so that's one of our traffic study tools. That is basically uses Power BI to connect to Waze Warp. We publish this template that is a file, and if you open it in Power BI and point it to your database, you can get the same functionality out of the Power BI template that we built. So I'm going to talk about, this is how we do, this is the last thing where we talk about how we do free on-demand traffic studies. So using Waze Warp and Power BI, this is just one of these cases. We can replicate $50,000 traffic studies for free, on demand, historically, etc. We did a blind test where we took an existing traffic study, for instance, and then had an analyst use the Power BI tool to do the same area, the same time frame using just historic Waze data, and it was 90% comparable to the results of the traffic study. And it begged the question of which one was more accurate. Was the traffic study that we paid for, where people drove around and stand on corners and clicked things and collected data that way, better or worse than the Waze data, which had millions of points of data over the time period across all times of day? And so we started to rely on the Waze data for many of these traffic studies. This is an example of some of the dashboards. That we wrote a blog post about this, and you can download the Power BI template and see how it all works from this blog post on our Medium blog. And maybe we can send out these slides later so you have links to all of this. And then another example of this sort of integration on top of the platform, we did a Masters of Urban Spatial Analytics practicum project with the University of Pennsylvania, their students, where they basically looked at the Waze Warp data and were able to use machine learning and built environment data and weather data and other information to predict at any time of day where the problems in our city would be as far as congestion goes. And so it's basically a congestion prediction system that is built on Waze Warp, and they published all of their code in the link below so that if you're running Waze Warp, you can basically reproduce this for your city. And it's something that we're going to start using with our traffic team. This was just released last week. They finished their practicum. And so basically you can use this as well. Instructions for how to deploy all this are on our project page on GitHub. An example of how easy it could be to deploy is the chief data officer in Anchorage, Alaska. He deployed it, the whole thing. He never looked at it before, but in 30 minutes, he deployed it from a commercial airline over their Wi-Fi and had it up and running, and it was collecting data before he landed. So if you follow the step-by-step instructions and have someone who's a little bit technical and a cloud account, you can get it up and running pretty quickly. So I'm going to just show you, and you can think about some questions to ask here, but I'm going to show you some of these things real fast. So here's our GitHub page. There's the sponsors, and you can read about issues and look at the wiki and the project plan and all that. There's a technical deployment guide right here. And there's a way to backload old data if you have it. Here's the study from the University of Pennsylvania. So they have a very long blog post about their methodology and how it all works and the code. And then finally, here's the Power BI template. This is a published version of it, but this is just one intersection. And so you can filter this by maybe a direction of travel, and you can see if you're headed westbound, Tuesday, Wednesday, or Thursday, then there you have a backup over here. And you can see there's probably an issue with this signal timing or light right here before you even get to the expressway. And you can see that it occurs in the morning based on the bottom chart. And so all this is interactive, and you can turn off and on different street segments are in the area. And this is one of 4 kind of tabs in this traffic study tool, including we have a pre and post change thing, so you can look at every month how things work before and after a time, date, and how it compared to previous ones. And we also have some other charts in here as well. So I'll go ahead and take questions now on all this. And thanks for listening.
Thanks, Michael. Very informative presentation. Generated a lot of questions. Obviously, too bad we didn't have another hour to dig into the details. So, an initial question: what are the steps a city or municipality can take to check to see if there's sufficient coverage in their area? Any thoughts on that?
Yeah, what we did, for instance, is once we had our Waze Warp database up and running, we could query that data and see where the reports are coming in. We can't see where people are driving necessarily unless there's congestion or unless they report something, but you basically can see the coverage area at that point. Another way I think that you can figure that out is if you contact Waze, they should be able to tell you things like active daily users. And I haven't asked them this, but I imagine they should be able to tell you coverage area and kind of where people are using it. I don't know if they could do that or not, but I would be worth asking them that question.
Okay. I think for Waze, typically you define a polygon area of what you want reported back on, and then inquire from them on monthly active users, how many miles driven by your users monthly. Unfortunately, at this point, I don't think they have a dashboard that provides that information.
Right. Yeah, you're right, Jonathan. And I think they may have a dashboard that provides some of that in the future, but not right now.
Great, thanks. So next question, are you aware of any limitations to the use of the data once you are engaged and are participating in the program, or is it are you free to use all the available data?
Yeah, there are a few limitations. You are free to use it as a city internally in pretty much any way you want. What you're not allowed to do is publish the raw data that you get from the Waze feed, and you're not allowed to share the structure of that data. Now, having said that, if you go to our GitHub page, which they support, you can see the SQL schema that is generated by Waze Warp with tables of things like jams and alerts, and many of the fields match up to what is in their data feed, and Waze has been supportive of this so far. So it's not exactly sharing their schema, but it's pretty close. But yeah, those are the 2 limitations that I would say, but otherwise it's free. You can use it. If you want to have another external entity that's not your city government use the data, you can add that entity onto your agreement with Waze. So for instance, we've added our local university, we added the University of Pennsylvania, we added our Code for America Brigade onto our agreement so that we can share that information with them.
Great, thank you. So we've got quite a few more questions here. Jonathan Ford's been answering some of them in the chat, so thanks, Jonathan. Maybe one last one before we have to move on, and we'll circle back after Matt's presentation if we have time. Do you use Waze data to create a response? So in other words, are you aware of anyone that might be actually using this data and initiating an action based on it, like sending a work crew to fix a pothole or broken traffic light and so on?
Yes, yeah, we definitely use it for that. So the good use cases are broken traffic light reports. The traffic team gets an email the moment that happens. So that's connected to the Waze database. If we get a report in that category, we trigger an email. And they think that's really useful to them because usually it takes them maybe a few hours before they really know about it otherwise. And then potholes as well, that actually goes into our 311 system, which then becomes just treated like any other pothole report. And yeah, there's a few others. We haven't done, like I said, the integrations with collisions, but we're looking at that, about pointing cameras at where collisions are and sending out a response using the Waze data. There's a few other minor use cases that we use with the data, but those are the big ones so far.
Great, thank you. For those that were scrambling to write down the links, I should have mentioned earlier that the session is being recorded and it'll be posted. So we'll try and see if we can provide access to the presentation slides as well. Yeah. So in the interest of time, we'll switch over to Matt Lee right now, and we'll circle back with Michael at the end if there's time for additional questions. So Matt, I'm just going to make you the presenter, and as you're getting ready, I'll just read your intro here. Just one moment. Okay, so next up is Matt Lee. Matt Lee is currently serving as Associate Vice President of Intelligent Transportation Systems for AECOM. In this role, Mr. Lee provides management direction and technical expertise in the areas of control room operations, motorist assist services, ITS field maintenance, transportation management center studies, TMC training, project budget management, bridge tunnel operations, performance measures and management, interagency coordinating efforts, and emergency operations. Additionally, Mr. Lee oversees an industry think tank on TMC operations and best practices, serves as a US DOT representative for integrated corridor management and regional concepts of transportation operations, and routinely participates as a technical speaker and/or contributor on TMC operations at national conferences and industry forums. Mr. Lee transitioned from commercial aviation industry to intelligent transportation systems in 2002. Formerly a director of ground operations for AirTran Airways, Mr. Lee graduated from Eastern Michigan University with a Bachelor's of Science degree in Aerospace Science and is based out of Detroit, Michigan. Over to you, Matt.
Great. Wow. That makes me sound pretty impressive. Thank you. Hey, with that, can you see my screen? I just want to make sure my screen is up.
Yes.
Okay, great. All right. Well, thank you, everybody. As the generous introduction went, my name is Matthew Lee, and I am based out of Detroit, Michigan with AECOM. AECOM currently operates we staff and operate 27 TMC operations around the United States, as well as we consult for about a dozen others. And one thing that we constantly get asked questions about is where is this industry going in the future? I mean, it's going to be changing dramatically over the next 25 years. And so in response to that, you know, we constantly have these workshops and opportunities for collaboration with our clients. And we created based on what our clients think this future will be and what AECOM predicts it to be, we created a video, which I'm going to go through with you today, that will demonstrate to you what operations will look like over the next 25 years. So with that, I'm going to start the video. At the end of it, I'll put up some contact information for myself. If you have any questions or have any desire to follow up on these topics, you can feel free to get a hold of me. But as we all know, over the next 25 years, our roads are going to be changing dramatically. Obviously, connected vehicles are going to be a big part of operations going forward. As soon as 2025, we're going to start to see things like autonomous vehicle lanes and platooning of vehicles to share data. We're going to see business meetings taking place on the road. We're going to see a lot more opportunity for increasing efficiency for people traveling to work. We're also going to see surveillance systems employed a lot more, and we're going to talk about that as we talk about the future. We're also going to see dynamic lanes and pricing take effect as we need to fund these technologies. We're also going to see drones are going to be providing visual systems, and road users will be less dependent on traffic signals and more on the information being distributed between their vehicles via connected vehicles. So as we go into the TMC of the future, I'm going to walk you through what it's going to look like from inside. First of all, we're going to see operations protocols and data analytics meetings. You know, up to now, a lot of TMCs have really been focused on real-time traffic operations and managing the incidents and events taking place on the road. But in the future, we really do think that where the TMC is going to come of age is in data analytics. There's going to be more focus on what data the TMC can collect from the new technologies as they're being implemented. We're going to see a lot more co-located, and right now we're looking at the TMC currently. We're going to see a lot more co-located and coordinated incident management taking place in the next 5 to 10 years. When I say co-located, that's with law enforcement and Department of Public Services as the TMC gets integrated more into the smart cities type of model. We're going to see the introduction of data analysts. The data analysts will play an important role in the TMC operation, even more so important than the control room operator. Control room staff will continue to monitor incidents. And as we go into 2025, let's look at, right now we're looking at 2025, where we're going to be in the near term. We're going to look at road condition data, and this is really between 2025 and 2030. We're going to see asset management really make an improvement in traffic operations, where road condition data from connected vehicles will be sent directly to the TMC. This information will not only be sent, but it'll be mapped via the connected vehicle data. And this is what the operator will be looking at. And it'll be sent and prioritized. These potholes or other road damages to infrastructure will be prioritized and automatically linked to the maintenance departments of DOTs. From there, the maintenance crews will be identified. What maintenance crews are identified will be sent out to the site to repair the damaged infrastructure. And statistics will be available to how many times the road was repaired and under what time frame. In performance management, we're going to see such things as weather integration in the next 10 to 15 years. We're going to also see the fact that we're going to look at predictive analysis. In that previous screen, you saw how weather will be utilized, historical weather will be used in predictive analysis analytics to determine or forecast what kind of event levels will be taking place every day in the TMC. We're going to have queue detections at intersections. Intersections will be obviously looking at how far the backup is and looking at alternate routes utilizing integrated corridor management techniques. And we're going to have an automation in the control room where currently the control room really focuses a lot on freeways. The control rooms will eventually start to look at arterial operations just as much and automatically and manually be able to implement signal adjustments to start flushing traffic. In incident management by 2030, we're going to be looking at what lanes are blocked automatically. Cameras will use data analytics to identify where the traffic is blocked, prioritize when the traffic blockage started, and prioritize the response. It will also automatically, instead of having the operator implement the information, it will automatically send out messages to all the DMS signs reporting where the event took place and giving travelers information. We're also going to look at roadway pricing will become a significant part of the future of traffic information as we implement more toll roads. Now we're looking at the center in 2045. So this is about 25 years out. Surveillance will be more on a regional level. Notice how we're also going to utilize the video wall for a lot of real-time traffic information and detection. The video wall will be a lot less about what's happening currently via the CCTV and more about data and what data is going through the TMC. You'll see it on the video wall up here and the video wall in the back. We'll be utilizing data analytics in real time to manage traffic. So again, we're going to look at asset management, performance measures, and incident management in 2045. As far as asset management goes, we're being constantly tracking in real time what our system efficiency is with all our field equipment. We're going to be confirming incident via the nearest mobile cameras. And we're going to be able to look at unmanned aerial systems, or UAVs, unmanned aerial vehicles. Will be helping to manage traffic incidents in the roads or the availability of infrastructure. Resources will automatically be deployed through advanced ATMS systems. And alerts will be sent to the motorist via their vehicles. In performance management, we're also going to be tracking that in real time. Oh, I'm sorry, there's a little bit of buffering going on with the video here. We're going to have also the TMC will be more integrated with modern technologies such as the maglev, bus rapid transit, personal automated vehicles, as well as rideshare will also be coordinated through the TMC. And the TMC will be sending messages directly to vehicles with information. All right, another thing in traffic incident management, the TMCs will be involved a lot more with police detection, and the TMCs will be helping in law enforcement. For example, if there's an incident with a robbery taking place, unmanned aerial vehicles will be dispatched automatically, and the TMC will be able to track vehicles from the event and be able to provide that information directly to law enforcement as they're dispatched from the police departments or from the police dispatch centers that are co-located. So that gives you an idea of what we're looking at in TMC operations over the next, I would say, from 2025 until 2045. It'll give you an idea how co-location is going to be playing a big role in TMC operations, and also how things such as decision support systems and artificial intelligence in the control rooms will be playing a much bigger role in what the traditional operator does in a TMC. With that, some of my contact information, if you have questions on any part of this or how it was developed, you can contact me at the attached link or the presented link.
Thanks, Matt.
Yep.
Very interesting content and very nice video for sure. Awesome visuals. Just looking at the questions here, just a reminder, you can add questions through the webinar info panel, so feel free to do that. So first question for Matt. This is a general one from me. So given your experience, obviously working with many different agencies across North America, there's also the recent announcement from Elon Musk that Tesla will be in a position to be ready to test fully autonomous vehicles within a year with any agency that provides permission to do so. Do you think this is going to change the game and change the timeline in terms of the acceleration and investment on the agency side to at least be prepared? What are your thoughts?
If anything, I think most agencies right now are already becoming prepared for connected and autonomous vehicles. The autonomous vehicle is going to be really coming into its own in about 5 years to 10 years, we predict. I think that even with Tesla advancing the technology faster, it's still going to take a while because infrastructure needs to catch up. I think some of the first things we'll see is autonomous transit with dedicated lanes for buses and eventually cars. But I don't think that Tesla is going to drive it forward much faster than the pace it's at already.
Right. Thanks for your thoughts on that. Next question we have here. This one's from Patrick Fitzhenry. The TMC of the future is clearly dependent on significant investment in ITS, AI/BI. How do you see the funding model changing to support this?
Well, I think it's going to definitely, one of the things that we focused in on this video, and part of the video had to be edited for time, but is going to be the implementation of managed lanes for pricing of managed lanes. A lot of the income is going to have to come through toll roads and through dynamic pricing on toll roads based on time of day in order to advance these technologies, because obviously construction and maintenance are always going to be the biggest, are always going to be the biggest groups utilizing DOT money for funding. But I think there's going to have to be some alternative means of getting funding for these ITS programs.
Great, thanks for that. Another question from my side here. Again, just given your experience and your work that you're doing across North America, what do you feel right now is the biggest opportunity that's not currently being taken advantage of? So what is cutting edge right now that agencies could be taking advantage of, but they're not? Is there anything that comes to mind?
Well, I think a couple things. Video analytics is definitely one of the biggest things that I'd like to see more agencies get involved with. Being able to utilize video to pinpoint accidents on the road and identify where they are is going to be, I think, is underutilized. And it's really, the cost of these technologies are coming down substantially, where you don't need a room full of control room operators to manage a TMC anymore. A lot of the technologies coming out are going to be able to be offset by reducing staff in TMCs, actually. And I think generally just technology like video analytics, things like wrong way driver detection systems, other things that are going to make it more automated in the control room as a way to actually save money and increase efficiency in the control room. And a lot of centers still like the traditional method of utilizing CCTV and control room operators, which I think we'll see changing dramatically over the next 5 to 10 years.
And what are you seeing from the agency perspective in terms of the mechanism mechanism that can be utilized to stay on top of that? Is it working groups, connections with the private sector? What are your thoughts on that?
I think it's working groups. Working groups are really the best way, and industry forums like ITS Canada and ITS America and World Congress are great ways to see what new technologies are out there and how they can be implemented. I think that's the best forum. Guest speaker series, I think, are a great thing, just as you're doing here today, to introduce people to new technologies and ways that they can perhaps advance their TMCs.
Great, thanks, Matt.
Yeah.
Another question here. What are some what are some of the data that municipalities can provide and make money from?
Well, I mean, gosh, that's a catchy one, because at least in the United States, municipalities aren't supposed to be making money from the data that they're collecting, being as a public agency, primarily funded through taxpayer money. But a lot of agencies work with some of the third-party traffic information providers like here and others. That's a good question. I don't know that there's a lot of opportunity to make money off the data, apart from the fact that you can save money utilizing the data through incorporating it into, your traffic management planning, integrated corridor management, things like that will be able to save your public user delay cost in traffic backups. I know that's kind of a roundabout answer, but I don't know if there's a way to an agency to make money off of data.
Right. So if we remove the data element from it, are you seeing agencies transition their TMC into a profit center instead of a cost center, whether it's by providing services to other business units or third parties, anything like that?
I see a lot of centers starting to integrate with managed lanes and dynamic pricing on those managed lanes, toll roads, and they're utilizing their TMCs to manage that dynamic pricing in those toll roads. And it's a way to not only fund their own operations, but also to fund some of the new technologies and also the general funds for construction and maintenance.
Right. Thank you.
Mm-hmm.
So it looks like we just have just under 10 minutes left. So feel free, all the attendees, any questions you have for either Michael or Matt, feel free to submit them through the question window. We'll try and get through them. Next question, another interesting one. Your thoughts on AVs being hacked? What can municipalities do to protect themselves?
Yeah, I think that's a good question. Obviously, with any new technology, we got to worry about it being inappropriately used. I think that AVs, a lot of that's going to come through the OEMs, and as far as the manufacturers of the vehicles and implementing security protocols in them. I think that that's going to be an IT issue that's going to have to be just as important as implementing AV altogether. Specific examples of how we can fight that's probably not my bailiwick, but it's definitely an important issue.
Right. Thanks, Matt. This question is actually for Michael. Hopefully you're still on the line there. The question is, how do you get counts from Waze? Is this sample data? Any thoughts on that?
Yeah, I'm still here. So you don't get traffic counts from Waze specifically. It's all aggregated, and in fact, even for a jam, you don't really know the number of vehicles that are in that jam. You just know the severity and the delay for anybody who happens to be in the area. Waze does have a second data feed, which they are working on releasing, which has a little bit more information like the actual speeds of the people driving in the corridor at any time. I don't know if it has counts though either. I think that they are shying away from that as a matter of privacy. So if you're looking for counts, you probably won't get it. Now, having said that, when we do our analysis of the jams at an area, we can't really tell the number of cars involved in those jams, but it's really useful information. So yeah, I hope that answers the question.
Thanks, Michael. Next question is for Matt. At any point, have you looked at this scenario where municipalities could purchase AVs and replace with traditional transit?
I'm not sure I follow the question.
Have you looked at the scenario where municipalities could purchase AVs? So I'm assuming it's making use of AVs in lieu of the traditional transit service offering.
Yeah, there has been some limited use of it right now in, I know that Minnesota, in Minneapolis, they've done some test studies utilizing that, as well as in California on a limited basis, as well as in Europe. They've done some use of autonomous vehicles for transit routes for streetcars. And I think that's going to be essentially, like I had said in the presentation, I think that's going to be the starting point for the use of autonomous vehicles is going to be in mass transit.
Okay, thanks for that. Next question. This one's for Matt again. Just wondering if it's possible to get an unedited version of the presentation that discusses funding options.
Funding options, well, the unedited version of the video is fine. I don't have any funding option video to go along with this.
Got you. Okay, next question. This one again for Matt. Are you seeing any places where the roads are being privatized due to municipal lack of funding? And if so,
yeah.
What implications do you see for government if the roads are to be privately owned?
Yeah, definitely. I'm seeing a lot of that around the country. Even here in Michigan, we're starting to see that as an option for increasing funding for the roadways. States like Florida, Texas, have all implemented, toll lanes and dynamic toll pricing by time of day to add these new technologies and to start to implement advanced ITS on their roadways. And I think that's going to be prevalent going forward. What was the second part of that question?
The second part, implications you see for governments if the roads are to be privately owned.
Well, it's usually through a public-private partnership, it's called in the United States, where it's a long-term agreement between a corporation and the government, where the corporation builds the road at their cost, and then they recoup their cost through operating the road for an extended period of time. It usually ends up being a win-win for both the government and the corporation. So I really see it as being a winning formula, these public-private partnerships. Obviously, these things become very political in the sense that toll roads are usually looked at as the last resort when because the taxpayers definitely don't want to pay more money, apart from their gas tax that they already pay to drive on the road. So politically, there's a little bit of risk involved for the politicians, but from a financial and an operational standpoint, it's definitely a winning formula for the government agencies.
Right. Thanks, Matt. This question is for Michael. So it was mentioned in your presentation that the partnership with Waze is just one of just one partnership for Louisville. Are there others that you're currently working with right now that might be somewhat similar or making use of crowdsourced data? Anything else that you can share?
Yeah, that's a great question. Actually, something I didn't mention in the presentation is because of the success of this Waze Warp project, we created a separate entity called the Open Government Coalition, which is a kind of a framework to fund similar projects like this that are managed by cities but paid for by other entities that are tangentially interested in the success of the projects. And under that umbrella of the Open Government Coalition, we have 5 other projects going on. They are not exactly the same as far as like a data sharing between a private company. They involve private companies, but for instance, one is a United States nationwide broadband crowdsourced speed test map to get really granular geographic internet speed test information as basically open data nationwide. Another one's about using if this then that to automate notifications of open data updates. And there's a few other ones. You can go to a website called, well, actually the Waze Warp project has a link to the Open Government Coalition at the top. So you can go to that GitHub page and then the website to learn more. There's another project though that maybe fits more closely to Waze in that it's the data sharing and it involves a private company. And that's something that many of you are probably involved with on some level, which is the scooter companies, micromobility, Lime, Bird, Jump, etc. So basically dockless vehicles in your city. And because those are in the right of way, typically on sidewalks and unattended, then the cities have the opportunity to request data from these companies, and there's already a data standard aligned around it. There's some tools built around that data standard that help you analyze the movements of origin destination trips with scooters and where you might need to put infrastructure. And so I think that's probably the next closest example, and one that when you're thinking about making these agreements with companies, make sure you specify that you want to have a data sharing agreement, that it should be in the MDS format, which is mobility data specification. And you can look to other cities for some of that policy language and some of those tools that have been built around that already.
Great, thanks, Michael. Lots of interesting initiatives, definitely to try and stay on top of. Well, it looks like we've hit the limit to our time today. Just to pass it over to Matt quickly, if anything that you wanted to say in closing, Matt, in terms of how people can reach you and so on.
Yeah, my information is up on the screen right now, and if you have any questions or want to talk about this further, feel free to contact me.
Thanks, Matt. And then any final words, Michael, from your side?
Yeah, I hope that you can share the slides with all the participants, and the links to many of the things you see will be in there. And I'll go ahead and add a link to the Open Government Coalition on one of the slides, so you can see that as well. And I want to thank ITS Canada, and I want to thank Jonathan Ford in Winnipeg for setting this up for me.
Yeah, thank you. Thanks, Matt. Thanks, Michael. On behalf of the ITS Canada ATMS Technical Committee, thanks for taking the time to participate today. We very much appreciate it. And thanks to all the attendees for their questions, making it interesting. Thanks again, and have a good day.
All right, bye. Thanks.
Thank you all.